Hello, everybody. We are starting the webinar, Logistical and In-Space Manufacturing Considerations for Human Mars Exploration with Karin Brunnemann. Today is September 4th of 2023. And thanks so much, Karin, to be with us today. And I will be reading some information about this webinar. This is a part of our Space Analog Mission 150, organized by Space Analog Station Habitat Marte. We are celebrating this great achievement. Also, this 150 mission is celebrating Santos Dumont, inventor. He's a Brazilian. And now it's also an initiative from Mars Group from the University Federal of Rio Grande do Norte State, also Rio Grande do Norte Space Forum, Mars Society Brazil, and Space Renaissance International Latin America. Karin Brunnemann has degrees in psychology and business information system. She's also studying intercultural business communications, and she is currently pursuing a doctoral degree in management. She has 30 years of experience working in and managing international projects in different industries, as has been focusing in the space sector for the past years. Karin is a consultant and project manager at several places and several companies and research organizations with a special interest in psychology and intercultural issues in future Mars exploration. She's a flight planner for the Austrian Space Forum, AMADI 24, analog Mars missions, and has participated in several virtual and in-person analog missions organized by Habitat Marte. Karin is also a project manager in research at Eco Encounter Space, based in Slovakia and Israel, and she's a lecturer and guest lecturer at various universities worldwide, discussing topics related to logistics, psychology, project management, and intercultural competence. And she is a regular speaker at space-related events and conferences. Thanks so much, Karin, to be with us today, and also your interest and also a great commitment in terms to encourage the interest for space and research about space exploration. You are very welcome to bring your points in your discussion, okay? I will stay with my microphone and camera closed, but I will be open during our discussion. You are very welcome. Thanks so much.
Yeah, thank you very much, Julio. Today will be hopefully a bit of discussions. There are more questions than answers in relating to this topic of logistical considerations for human Mars explorations. As we will see, we are not quite ready to go. But I think it's an important group of topics, actually not a single topic. And I wanted to bring it a bit more to the forefront of discussions in Mars exploration. So to start, if we look at a very high level of what is logistics, now we have a flow of goods that goes forward from point A to B, but also can go backwards from B back to A. We're talking about flows of information. We need to consider also flows of energy and also financial flows. And if we're talking human Mars exploration, then of course we're also talking about transport of people. Now we are on a very, very high level of defining logistics, but for today's webinar, it's enough to give us some sort of a guideline for our discussion. And I would like to ask Julio and also Jay to discuss with me what do we have to do, what do we have to send to Mars before we send the first humans?
There is some discussion about send robots or humanoids to Mars before send the humans, because these robots would have a lot of sensors to identify the safety for human presence on Mars, and also how mainly the atmosphere conditions. And this would be interesting in my point of view. Also, just have some kind of robots like the rovers exploring Mars, and this probably is the first step before to send human to Mars. Yes.
Yeah, it's also interesting that Mars is currently the only planet entirely inhabited by rovers.
Yes, that's quite a thought. On my side, if I were to say, maybe we would need all the robot help, the robotic help that we could get. We would need the solar panels for energy. We would need habitation. We'd need water. There's also concern of if we are going to get water from the ground, we need to make sure that water is actually not got biologicals in it that could pose a problem. So whatever landing site we might think, it might be really good to actually do some analysis of certain DNA or methodologies, just to make sure that there is no actual life in that water that we're going to be drinking or using. But hopefully on the moon, we can also have some practice before we go to Mars as humans.
Yes, absolutely. Here are some additions to the shopping list. Yeah, we need to send construction robots so they can actually build habitats for the first humans or other structures that are needed, like a launch pad, if we want to send them also back. Yeah, we need probably some tools, some consumables for these robots. We need to send spare parts ahead of time. I would presume that we would also have to send 3D printing equipment for in-space production of certain things. Yeah, we need to probably send some building material, presuming that not everything can be made from Martian regolith. Yeah, then we might need some different materials for certain things, like some metal or carbon fiber material that cannot be found in situ. We, of course, have to send ahead food and beverages for the settlers. And we have to make sure that there is plenty of it, because it can, of course, happen that once we send humans to Mars and we calculate we will send another rocket right after to bring more supplies, there can be bad weather or anything that prevents that rocket from launching, or in worst case, it can be destroyed. And then there will be a group of humans on Mars without sufficient provisions. Yeah, so it's very important that we have not only food and beverages for the plant consumption, but also a plenty of reserves. We need to send products for personal use. Like they need clothes, they need items for personal hygiene, like soap, shower gel, whatever they're using. We also need to send medical equipment and pharmaceuticals in case someone gets sick or gets injured. So everything has to be there before humans get there, because if we really send a group of humans, there will not be too much space for payload on that very rocket that we send them with. And also some electronic equipment. Yeah, we're not able yet to 3D print a laptop. Yeah, So we need to make sure that all these things will be waiting there for the first humans, and that will pose a challenge in itself. And this list is by no means complete. Yeah, so we will find more and more things that we need to make sure that is available. And we also have to make sure that, for example, if we send large supplies of food, it's of course only non-perishable items, but we also have to make sure that they don't get the food doesn't get destroyed by space radiation, which is very prevalent on Mars. That it's actually been suitable for storage in the Mars environment. The same with all the other things, of course, especially also medical equipment and pharmaceuticals. So there are a lot of challenges there, and we can probably make an endless list of items that need to go before we settle on Mars. Yeah. Any questions or comments regarding these?
This week, in this first week of September, was announced in Twitter the possibility about the use of Starship as a station in our atmosphere surround the Earth. And also, interestingly, Elon Musk publicized a video inside the cargo area of Starship. He's showing how big is the Starship in the cargo area, and how this would be a very logistic vessel, or very interesting way to transport and a lot of things to Mars, and also how possible station based in our atmosphere.
Absolutely. Yeah. So then the next question is, talking logistics, which of course also includes transport, how we will get around on Mars. You know, we have some vehicles there, we have already rovers there, we have a helicopter-like thing there, Ingenuity, which has outlived everyone's wildest dreams in terms of performance. So that was a big positive surprise that we can actually fly this kind of it's not a helicopter, it's not a drone, it's just this flying object, that it's actually possible to get long-term service from such a vehicle. Now, we might have drones for exploration and for transporting things, but that also means that for these vehicles we will need spare parts. We will need provisions for maintenance and repair. Yeah, we will need some kind of fuel for these, be it including the fueling infrastructure. Yeah, if there are all electric vehicles, we might need a battery loading station, or whatever we're going to use for powering them. We need to have probably some kind of paths. I wouldn't go as far as calling them roads yet, but there should be some safe paths from A to B, without cliffs, without big boulders that can lead to damaging equipment or injury to humans if they're out on an EVA. And we also need to some kind of navigation system. Yeah, maybe we start with the old-fashioned paper map that we used to have decades ago. But there's obviously not, or at least not yet, any navigation system installed on Mars. So we have also in the AMAD missions, we have made some experiments with using waymarks, a specific formation in the landscape or a kind of a mountain, to use these as navigation points, as waypoints. But we are still steps away from having a proper navigation system on Mars once we're there. Yeah, comments from your side?
Yeah, one of the points is think about how these vehicles will be charged. If they will be based on solar panels or some nuclear fission, and also these questions also important to think about the autonomy, how many kilometers or how many miles they can move from the main station, and this would be interesting points about how they, also very important point about how they how the energy would bring the conditions to explore the wilderness on Mars.
Yes, absolutely. Also, how we construct them to make it possible to overcome obstacles. Maybe there are some crevices, how to navigate them. It's again, it's been started with the rovers, and we still have some way to go. Yes, Jay, please.
I was just really interested about the waypoints and just navigation, because of course we probably won't have any GPS satellites. And so looking at surface features, that's one way. I just also thought, what about perhaps raising some kind of a cell structure of masts? So imagine if you could raise like a mast that was about 20 meters above the surface, or 10 meters or whatever, and you had a whole cell-like structure around your base. So you could then triangulate the signal between these masts to know which cell you're in and how close you are to the edges of the cell, perhaps. That might be something that might be quite inexpensive to do. But of course, further out exploration, you would maybe need other things. Maybe there is a way of triangulating signal with existing satellites above Mars at the moment. I'm not sure how many satellites are above Mars at the moment, but maybe there's some kind of a signal triangulation that could also be done with them.
Yeah, good points. Yeah, the masts, I think they will work quite well in the vicinity of a settlement. Yeah, so in the area close to where humans will live. And for further exploration, they would, of course, have to build further masts that are further away. There is a lot of research on the way, and we obviously have to come to a conclusion how we're going to do it before we send people there. As I said, when I was a child, we had paper maps, and we would still find our destination. On Mars, it might be a bit more difficult because Mars is not fully mapped, yeah, to the extent that even a 20 centimeter step in a rock might be an obstacle to a rover, where we say the rover can't go there. Yeah, so we don't have this kind of map yet from Mars. So it'd be interesting to see how we proceed around transport and exploration on Mars with vehicles. Yeah. And it's also interesting to discuss, will it be autonomous vehicles going on their own? We will certainly also have some vehicles driven by humans while they're on Mars. Yeah, some kind of, we have seen the moon cars. We will certainly have Mars cars. So that's also something that needs to be discussed in more detail. Yeah. Then, of course, closely related to navigation system, how will we manage information flows? There's, for one thing, it's information on Mars between different people or maybe groups of people living there, but also between Mars and Earth. Yeah, because depending on the distance between Mars and Earth, which is constantly changing because they're not rotating, they're not orbiting the sun in sync, obviously, there can be up to 20 minutes delay for receiving signals. So steering a Mars rover from Earth is impossible because you have 20 minutes, the thing has already gone off the cliff, yeah, before you're able to tell it to stop. Yeah, this is also when we talk about humans, it's impossible to make a phone call from Mars to Earth. It's possible from the moon to Earth. Yeah, it's a bit annoying because there's like a couple of seconds of delay. Yeah, so you have to maybe wait for 3 or 4 seconds to get an answer if you ask a question, but that's doable. But you can't be on the phone line or satellite phone. If you ask a question, the question is received on the other side 20 minutes later, and your answer will get to you 40 minutes later. So it's just not possible to exchange information in that way. So we have to work with a greater autonomy on Mars. An interesting example is that Nokia actually won a contract from NASA for setting up a 4G network on the moon. So we'll soon have Wi-Fi on the moon. And we need to see if we can duplicate that setup then for Mars to connect maybe different stations, to connect a landing and launch pad with a settlement, with a habitat where people are actually living, because if a spaceship arrives, people will have to communicate between themselves. Yeah, so we have to find a solution for that as well. Yeah, to get grips on the information flows. It will be very asynchronous. Any thoughts on that from you?
I believe for Mars exploration, it will be necessary really something like autonomy system, because they probably will be necessary terabytes of information, and the system need to operate like off-grid, based in the information in shared on Mars, based on Mars, and created on Mars, and probably the support of artificial intelligence to help to process all of these local informations based on Mars, and also probably the information, the connection with Earth will be based on batch of informations that will be sent, like in blocks of information sent from Earth to Mars, and from Mars to Earth. And we need to see how 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 about the fidelity of this information, because information travels like during a long journey, and how these information will be arrive on Earth or arrive on Mars, and these are interesting topics to think about the future of space exploration, I believe.
Yes, absolutely. And if we are sending the first settlers, we will, as you said, we will generate terabytes and terabytes of information from all the data they're collecting. They will record a lot of videos. They will collect scientific data. And yes, we certainly need artificial intelligence to help aggregating the data. Yeah, because in the best case, we send results, findings, scientific findings back to Earth instead of raw data. Yes, we need to certainly have some batch processing. We can't have a line that is open all the time. Maybe there will be one for monitoring medical data, but I also doubt that a bit, because that will be horrendously expensive if we have if we send data continuously in real time, especially as it won't be received in real time anyway. So maybe there are 1 or 2 windows per day in which we send the data in batches from Mars to Earth and vice versa. Yes, Jay.
It's also really interesting to think about the things that we're really dependent on, like, for example, the internet. Anytime we want to know anything, we can Google that information within a matter of seconds. So if there's any emergency information that we need, it's a few seconds away. But if you're now on Mars, imagine having to wait 30 minutes for any particular web page to open. So that could create quite a challenge. And perhaps one solution is to upload certain cached versions of the internet every night over to Mars. Like, for example, might be certain medical things, or even social media that's happening. For example, Facebook could do some kind of a sponsored thing where they upload a certain amount of information to the Mars server. So imagine anytime you want to use the internet, you would access it through the Mars server, and then the Mars server could see like what kind of things and what kind of information people on Mars are finding most useful, and that perhaps could all be cached ahead of time while the people are sleeping on Mars, and then be available the next day. It wouldn't be perfect, but it would be better than waiting 30 minutes for the information.
Of course. Absolutely. Yeah. Then another topic that we need to address are energy flows. Yeah, how do we power our life, our work on Mars? Which form of energy do we need? Yeah, are we using solar energy? Are we using wind energy? That's also a possibility on Mars because there's some strong winds. Are we using nuclear energy? And how do we transform this? Because it's obviously we can't produce energy, because energy is a given in the universe. We can only transform it from one stage into other. We can transform kinetic energy into thermal energy, but we cannot create energy. Yeah. So how do we transform energy? Yeah, from what to what? Yeah, maybe from kinetic energy of wind. Maybe we have a wind turbine to thermic energy, yeah, for heating the habitat for the people living there. Yeah, and also how do we distribute it? Yeah, if we have solar panels, I want to convert the solar energy to electricity, maybe to charge a battery in a charging station for a rover. How do we get it from the solar panel to the loading station? It has to be a bit away because battery loading is dangerous. Yeah, batteries can explode or catch fire, so it can't be inside the habitat. But it shouldn't be too far away, so it's still accessible. Now, how do we get it? How do we get there? We can't probably use kilometers of cables, because how do we get the cable there? It will be very costly. So that's also a question that has to be answered if we are talking about powering our settlements on Mars. Maybe rovers they have their own solar panels. Yeah, they take them with them, but that's obviously not possible for each and every vehicle. It's also not possible to have collect the energy exactly where it's needed all the time. It's of course the ideal scenario. Yeah, the habitat can have solar panels and a wind turbine right outside the door. But it's different with, for example, battery loading station. Yeah, as we've also, like in Habitat Marte, we actually built a separate kind of a room for the battery station that is separated by a wall from the lava cave habitat, in order to minimize the danger of people staying in the habitat. Yeah, so it needs cables. Yeah, it needs some way to get the energy from A to B, from where we collect it to where we use it. Yeah. Comments regarding that?
Yeah, probably will be something like energy matrix, because will be safer if they have different sources of energy. For example, from the sewage treatment plant based on Mars, probably they will generate gases like methane gases, and this will be interesting to generate energy from the composting process, only complementing the examples. In this case, there's several possibilities in terms of energy generation. It would be good not be dependent by only one source, but have many possible sources. Will be safer to the crew there.
Absolutely. And this is also a great, I think, gateway to push sustainable energy here on Earth, because on Mars we can only use renewable energy. We don't have fossil fuels on Mars, at least not that we know of now. So we need to rely on solar energy, on wind energy, on energy from human waste, on maybe nuclear energy. But nuclear energy is also it needs a lot of infrastructure, so it's not so easy. Yeah, Jay, what's your take on this?
The solar power, for me, that seems like the best and most efficient and most tried and tested means of energy production. We know on Mars, based on using it for the rovers and things like that. And obviously the rovers will charge their batteries overnight, as I understand. I'm not sure. I think it works like that. There's also a concern of storage of the batteries, because I think the surface temperature is somewhere between, the minimum goes to minus 110 Celsius, mean of minus 60 degrees Celsius. So imagine you're trying to store a battery. You would also have to maybe warm the place that your battery is actually being stored, which would also cause your energy losses and things like that.
Yeah.
Being able to transfer power, you could potentially, if you don't want to go the cable route, you might even be able to transfer power with lasers, or maybe there's some kind of other wireless means of transferring energy. We could also use mirrors to gather. We don't have to necessarily have solar panels only. We could use large reflectors to create almost like a reflector powered station that was like driving a steam turbine or something like that. So there's lots of ideas. There's also, I think, a lot of companies are working on kilopower nuclear reactors. So very small transportable nuclear reactors, for example, what maybe submarines might use, things like that. So there's some really exciting things that are being done for power. So there'll probably be quite a few options. I've got a concern with the wind power, that would we have enough, would the atmosphere be thick enough to provide enough mass or kinetic energy flow through the turbine blade at that level of pressure to create enough power? So those are.
It's certainly, wind power cannot be the only source of energy. It can support the solar energy, because imagine there is a dust storm on Mars. There is no sun shining. Yeah, so, but there will be a lot of wind, and very strong wind. What I think it's more of a concern to construct the blades in a way that they withstand the constant sanding. Yeah, because it's bombarded by sand particles, and that can of course destroy these panels. So, but I don't think we can rely. We should rely on one single source of energy, collection. We should actually consider different ones.
Yeah, one of the points about not forget, and also about the propellants production, because also a great part of the discussion is related to propellant production. Also, aboard of the Perseverance rover, we have the equipment called MOXIE, and one of the roles of MOXIE is produce oxygen and water and nitrogen. And the MOXIE is very interesting, because for Mars they need to have a plant many times bigger compared to the regular size of MOXIE aboard of the Perseverance. And the MOXIE technology is very interesting, because they need to produce propellants for the rockets to come back to Earth.
Yeah. Also, if we're using nuclear energy, it would of course be better if we could use nuclear fusion, but we haven't figured that out, how to use it on Earth. So there is still a lot of work to be done there. Yes, Jay, please.
Sorry, just Julio gave me an idea there, speaking about MOXIE and oxygen production and the rocket fuel. So of course, some scientists have ideas of creating rocket fuel on Mars. I think using a combination of methane and oxygen. And if you have already a production facility that is, obviously this would probably be some time down the line, but perhaps even before humans come to Mars, we might already have meaningful production systems of methane and oxygen. And perhaps there is a new type of fuel that we could have in canisters that could be kind of like a methane and oxygen canister fuel. And if there was perhaps no solar energy available, we might have systems that could go straight onto methane and oxygen fuel, perhaps.
Yeah. Which brings us to the next topic, really. Getting to Mars and back. Yeah, ideally we have sustainable rocket fuel, and of course including fuel to get back to Earth from Mars. I've been working over the past years with a Slovak startup in cooperation with ESA. They have created a specific structure of wax-based hybrid rocket fuel that is very easy to handle. Actually, you can eat it. It doesn't taste nice, but it's not harmful. It's wax, and you can handle it. It cannot explode. It doesn't. Yeah, it doesn't even burn. Yeah, if you want to burn a candle, you need to have a wick to start it. Yeah. So it's a very safe type of fuel. And they also did experiments in storing this fuel for several months in a Mars-like environment, like very cold, and then put it into the rocket and did a hot fire test. And it went very well. It's still, despite being stored on the Martian conditions, it proved that it's capable to ignite again. So there are several initiatives. So we have to consider that it's, of course, ideally it's sustainable. Ideally, it's very safe. Yeah, methane is not safe at all. Oxygen is not safe at all. It needs to be storable on Mars. And ideally, it's also producible on Mars. So we don't have to bring it back and forth. Again, we're not there yet. Yeah. What we also need to consider is on Mars to have launch and landing pads, including all the infrastructure. Yeah, the cooling of the launch pad, the tower that holds the rocket in place, and all these things. I mean, it's Julia has just seen it in the US. It's an awful lot of infrastructure that we need to have for launching a rocket. Yeah, maybe we'll have some docking structures that actually orbit Mars permanently, where we can just have a docking operation with a maybe lighter vehicle that lands from this orbital docking station on Mars and launches back to the docking structure. And for the docking structure, we can send starships without having to land them on Mars. Something like that is also possible, or thinkable, at least imaginable. Yeah, we need to urgently address the issue of space debris. Yeah, there is too much already in orbit now, and if we make Mars habitable, we can't leave Mars orbit and Earth orbit completely littered with rocket stages, with all sorts of things that are currently old satellites, whatever is orbiting there now. So we have to find a solution for that before we go to Mars, because imagine we send some humans to Mars for a mission. Yes, go there for about half a year, stay for half a year, come back for half a year. While they're on Mars, there is a collision in low Earth orbit that actually causes a chain reaction and makes low Earth orbit unusable. that can happen. How will we get these people back from Mars? Yeah, we can't take them through low Earth orbit because it's totally cluttered with debris and it's too dangerous. So that's also something we have to solve before we go. And we need to work on so-called logistics reduction technologies, yeah, make things smaller, make things lightweight. So we can bring more things to Mars, or we can bring the same amount of things to Mars for a much lower cost. Yeah, so these are some of the considerations that we need to address before we can send humans. There's lots more. Any thoughts on these?
The thing that just came to mind was the reduced gravity on Mars, the 38% gravity. % of the escape velocity of Earth. So we need less rocket fuel to send stuff from Mars back into orbit and things like that. There's also some interesting things that are being done on Earth. There's a spin launch system, which is basically, I think they call it a suborbital accelerator, which they spin things really fast and release it into the like a satellite. I think they can release a 200-kilogram satellite into orbit using the system. At least that's the plan. And perhaps on Mars, where there's very low air pressure and a reduced escape velocity, perhaps we can launch a whole network of satellites into Mars, or just things off the surface much more efficiently than using rocket launches.
Yes. Also, that could help sending things from Mars to a potentially orbiting docking structure with these spinning launch systems. I've seen them in action. They're pretty interesting. So that is certainly also an option. I don't know about satellites, because when I want satellites in Mars orbit, I wouldn't land them on Mars to launch them from Mars. I would just go close to Mars and launch them there. But maybe in the future, when we have more in-space manufacturing and we're actually building satellites on Mars, then that is, of course, a very interesting option.
Yeah, also, Karin, something very revolutionary will be a new category of rockets based on nuclear fission. And because, as you mentioned, this will be very disruptive in terms of maybe these new kinds of transportation will be lighter and also important to wins the Mars atmosphere. And this one of also the Mars atmosphere is 1/3 of in terms of gravity compared to Earth. And these if with a nuclear fission rockets would be lighter to wins the Mars gravity, and this will be one of interesting things. But also for 2024, there's some tests of this new technology, and maybe you have good news about this technology, because this can be a very great change in terms of space exploration. Also faster travels. Instead 7 months traveling, this travel from Earth to Mars be happening around one month.
Yeah, that would obviously be a great breakthrough. So, as we see, there is still a lot of aspects that we need to discuss, that we need to solve a lot of challenges that are ahead of us. Any more questions or comments in relation to Mars logistics?
Yes, and just thank you for this talk. I've really enjoyed participating and also just learning and thinking about the logistics. So yeah, I really appreciate you putting this together, and it's given me some things to think about. I'm very interested in the next steps, going to the moon, and I think there's firstly we can practice with analog stations like the work that Julia is doing, and I think all nations of the world should actually get behind analog stations and supporting them. It's really important work, and we can really see how things work on analog stations before we risk sending humans to the moon or to the Mars. So for me, the next step would probably be more investment in analog stations and technologies, then creating some stations potentially on the moon. So I'm interested to know, one of my questions to you, Karin, is you're interested in the moon and maybe testing out some of these logistics first on the moon. Another thing that I think becomes really important is accountable leadership structures and decision making. So if you have an emergency situation that comes up and you have a team of, let's say, 15 astronauts on Mars, how do you quickly resolve those decisions where a single mistake could mean everyone does not make it in that base? It's very high stakes thing. You're working in a highly pressurized environment. There's so many risks that you're constantly facing. So you need a way of really having a decision-making process that takes everyone's opinion, where people's opinions can be heard, their thoughts can be heard, because again, a single mistake is just is so serious.
Yeah, and we have to let me just add to what you just said.
Sure.
There will be decisions that have to be made within split seconds. We will have to make decisions where we cannot ask everybody for their opinion, and we will not have time to discuss. Yeah. So we have to also consider that we give enough decision power, but this is more like a management / space psychology question rather than logistics. We need to consider both scenarios. Yeah, that we have consensual decisions where the entire team is involved, maybe even mission support on Earth is involved if we have the time. But sometimes you have a split second to react, and then the person who is closest to the decision-making point, they have to make the decision, and they have to make it without waiting for an answer, because then it's too late. Regarding, yes, your remarks about analog missions, it's getting more and more important. It's also getting more and more urgent. We still see a lot of effort when it comes to Mars exploration being focused on hardware. Yeah, let's build a rocket and let's go there. But we don't know how humans will collaborate, how we will live on Mars. And for that also, Habitat Marte is actually the only analog station in this universe who can actually simulate a Mars city with several habitats apart from each other, not too far away, but distinct habitats where we can also start simulating how can we cooperate between habitats on Mars. And this is a first for Habitat Marte, and that can also help to investigate a lot of logistics challenges that we will face, because also on Mars we will have separate structures. We will not have one kind of building and everything is there. Yeah, we can't have a rocket launch pad where people are living. It's not possible. So we need to have different structures, and we need to experiment and practice on the coordination and communication between different structures. And I think we have the Space Habitat event in, Julio, remind me of the date.
It's November 8th to 11th. Around.
November 8th to 11th, where we will discuss also some of the logistics topics that we touched upon today. We will discuss them in more depth, and we will discuss other relevant topics as well. So if you're listening to this on YouTube, please put the dates in your calendar. We will make announcements. Follow Habitat Marte on social media, so you will not miss the next events.
Yes, also if someone is watching some years after yes, this video, yes, Karin mentioned about the Space Habitat event, and all presentations will be shared in Habitat Marte channel. In this case, the youtube.com/Habitat Marte.
Yes, and of course, everyone is invited to participate in either a virtual or in-person mission at Habitat Marte.
Yes.
You can just contact Julio or myself if you wish to participate. And it's a very interesting experience. It will give you a lot of new skills, a lot of interesting experiences. So I can highly recommend it. And I actually don't get paid for this. So it's my sincere belief. We need everyone. We need astronauts on Earth to prepare us for going to the moon permanently, and also for Mars. So Habitat Marte is a beautiful habitat, or group of habitats, actually, Mars City. And it's a very, very great experience to participate in the mission.
Yeah, thanks so much, Karin. Yeah. Also, something interesting is also think about geography, because also we are based in a semi-arid place with a lot of cactus in our landscape, beautiful cactus, large cactus, and also on Mars will be a very beautiful landscape to explore too. And you need to analog this magnificence between watching the both geographic sites on Earth and on Mars. Yes.
Okay. So thank you very much. And I hope to see you in the Space Habitat event in October, or in one of the upcoming missions at Habitat Marte.
Yes. November, okay? Yes, November. Okay, thanks so much. Thanks, Jay, for your participation.
Very much.
We keep in touch. Thanks so much.
Thank you.